Let's solve this calculus problem step by step. We need to find the second derivative of y with respect to x and prove a specific relationship. Let's start with our given equation. We have y equals the natural logarithm of x plus the square root of a squared plus x squared. To find the first derivative, we'll use the chain rule. Remember, the derivative of natural log is 1 over the function times the derivative of the inside function. Let's apply this. The first derivative, y1, equals 1 over x plus root a squared plus x squared times the derivative of the inside. For the inside derivative, we get 1 plus 1 over 2 root a squared plus x squared times 2x. Now let's simplify this expression. We can rewrite this as 1 over x plus root a squared plus x squared times x plus root a squared plus x squared over root a squared plus x squared. This simplifies beautifully to root a squared plus x squared times y1 equals 1. To get rid of the square root, let's square both sides. This gives us a squared plus x squared times y1 squared equals 1. Now, for the second derivative, we'll differentiate this equation with respect to x. Using implicit differentiation, we get 2 times a squared plus x squared times y1 times y2 plus 2x times y1 squared equals 0. Finally, we can divide everything by 2y1 to get our desired result. A squared plus x squared times y2 plus x times y1 equals 0. And there we have it. We've proven that a squared plus x squared times y2 plus x times y1 equals 0 through careful application of differentiation rules and algebraic manipulation.